In this video, I'm going to be touching upon the idea of increasing and decreasing functions. So you may see this something like a question asking you what are the values of x for when the function is increasing, and what are the values of x when the function is decreasing. And so what does this even mean? Well, basically, if I draw out in a coordinate x over here, x and y, and I sort of give you guys, let's say a parabola over here, then see this is the minimum point of the parabola, right over here, this minimum point. And the value they want is, let's say, at this minimum point, your x is equal to 2. So the values of x they want for when the function is increasing are basically all of these values, all of these values. And why is that? Well, it's because as you sort of, if you're on this point, x equals 2, and you sort of start walking towards the right, then what's happening is your values sort of increase and increase and increase and increase. As your x coordinate is increasing as you're going towards the right-hand side, your function values or your phi values are going up, which means it's increasing. So the value of x for which the function is increasing would basically be x is greater than 2. And let's say if they asked you the values of x for which the function was decreasing, then you would have said, well, that is x is smaller than 2. That is when the function was sort of decreasing, because let's say you're over here, right? Or you're over here. Let's put you on the curve. So you're over here. Oops, over here. And as you're sort of going to the right, or as you're sort of going down, you can sort of understand it like that. What's happening is well, as you go down, if you're on some x coordinate -3 over here, when you come to this point, you have moved someplace to the right, and now you would be on -1. And what's happened is your y value, over here you were on this y value, now you're on this y value. So as you went to the right, your function decreased. So the function is decreasing for values that are lower than x equals 2, and they are increasing, the function is increasing for the values where x is greater than 2. And you can even go ahead and do this for let's say a cubic function. So when you have a cubic function, you now may have two points, two stationary points, one may be up there, one may be up here. And over here for this cubic function, you can see that if they ask you for when the values of x for when the function is increasing, let's say this guy is at -1, and let's say this guy is at x equals 5. Then basically there are two regions where the function is increasing, and they are these regions. So the function is increasing, you can see that the values of y was lesser over here, somewhere over here. Oops, let me just get that back. So the values of y were somewhere over here, and when you reached the top point, they were somewhere over here. And then in the same way, the values of y were over here, and then as you sort of went around, the values of y sort of increased to this level. So these two are the regions where the y values are sort of increasing, or in other words, the function f of x are basically the y values. These guys are the y values. These are sort of increasing. So the values that you will quote for which the function is increasing will basically be x is greater than 5, and then you can say that x is smaller than -1. So these are basically the two sort of x values where the function is sort of increasing. And between these two regions over here, you can sort of see this part is where the function or the y value sort of decreased. So as I was over here and I went to the right, I was also going down. So if you start walking towards the right, so if this is a hill and you start walking towards the right, you're going to go over here. So you're going down. As you're trying to walk towards the right, you're also going down. Okay, and so all of this part is if I draw y axis and x axis, as you're sort of going to the right, your y value is sort of decreasing. So between x is greater than -1 and x is smaller than 5, that's sort of where your function is decreasing. This is where your function is decreasing. And the way you can use derivatives to find this out is basically what you need to do is you need to construct a number line. On that number line, the bottom region is going to be the region for all of the x values, and then this top region is going to be for the dy by dx values. And hear me out really carefully. So I'm going to make some room over here. Let's erase this stuff over here. Let's make some room. And what you're going to do is, let's say, oops, I wasn't supposed to erase that box, is when they will ask you, they will give you a curve, they will give you y equals something, something, something. And they will say for this curve, or this, let's say it's a function, and they will say for this function, tell us the values of x for when the function is increasing. And let's say for our scenario, that function happens to be a cubic function, right? Just for example, of course it could be a parabolic function or whatever. But let's say for our scenario, that's a cubic function. Now remember, you cannot see this function because you have not plotted out the graph. So you're in your mind, I'm just telling you this as an example, this would be x to the power 3. That's a cubic function. And on a graph, it looks like this. Now you will not plot out the graph. Instead, what you will do is you will use this method right over here. And the way you will do it is you will basically first differentiate the curve. So this is dy by dx, you've differentiated the curve. Now what you will do is you will find the stationary points. You will find the points where the gradient is equal to 0. So you will put the gradient equal to 0, and then it will give you some x coordinate. Let's say those x coordinate, if you're talking about this graph, let's say those x coordinates happen to be -1 and 5. So what you are going to do is you're going to put a line over here for -1, that's the x coordinate, and then somewhere over here that as 5, that's the y coordinate. And then in the derivative section, in the differentiation section, you're going to put a 0 over here, so that 0 tells you that this is a stationary point, and you put a 0 over here, that tells you that's a stationary point. So looking at the graph, those two stationary points are this guy and this guy. Now what you're going to do is you're going to test the sections. So you've basically divided your number line into 3 parts. You've divided it into this first part, this second part, and this last part. Now what I need you guys to remember is that when dy by dx, when this thing is positive, that's when your function is increasing. That's when your function is increasing. When this guy is negative, that's when your function is decreasing. Okay, so now what you're going to do is you are going to have your x values down over here, and what you are going to do is you're going to pick out one x value from each of these sections. So let's say from this section, from the first section, you pick up any value that is less than -1. So you can pick a value of, let's say, -1000. And then what you are going to do is you're basically when you're going to go back into the dy by dx equation, and of course it's going to have some x as its input. You are going to put that x in there. You're going to solve it out, and you are going to see if your differentiation is positive or if your differentiation is negative. Now, if it is positive, that means your function is increasing. So if this side comes out to be positive, that means your function is increasing. If it comes out to be negative, that means your function is decreasing. And then you're going to do that same thing for the next section. So you have -1 and +5. You can pick out any value between these two numbers. So let's say you pick out 0. Now I'm going to go back into your dy by dx equation, and inside of it you are going to put your x as 0. And then you are going to check if this thing comes out as positive or if this thing comes out as negative. So let's assume that this thing happens to be negative. That basically means that at between -1 and 5, your function is decreasing. And then for the last section, you pick up any value that is greater than 5. So let's say you pick up 10. You can pick up any value. That's completely up to you. Now you're going to go back to the dy by dx equation, the differentiation equation, and you are going to put your input as x equals 10, and then see if this thing comes out to be positive or negative. And then let's say this thing comes out to be positive again. So what that means in case of our curve is if we go back over here, it makes sense. Now you won't have the curve, but it makes sense because look, the first thing you did was you found out these stationary points. And then what you did was you first checked out this section, then you checked out this section, and then you checked out the last section. So this, basically the first section, this is where you got your positive gradient, and that's where your function is increasing. So you would get your positive gradient. For the next part, your function was decreasing. That's where you get the negative gradient. And then for the last part, again, your function was increasing, so you got the positive gradient again. Now, of course, if you do this process with, let's say, a parabola, so let's say if you do it with something like a parabola curve like this, and let's say that the x-coordinate of this point, let's say the x-coordinate of this point is 5. So then when you basically construct your number line, you're going to have your dy by dx up here, you're going to have your x down here. What you're going to do is you're first going to find out the x-coordinate of the stationary point. How are you going to do that? Well, you have this dy by dx equation. You will just put dy by dx equal to 0, and then you will solve out the equation, and you will get some value for x. So in this case, that value of x is 5, and that's where your stationary point is. And then you will check out this side of 5, and you will check out that side of 5. The point is, in this scenario, in this situation, you will only have 2 sections. And that's because you're dealing with a parabola. It only has 1 stationary point and just 2 sections. But in the case where you were sort of dealing with a cubic curve, that's where you had 3 sections. In the same way, if you have a I don't know what the curve x to the power 4 is called, but with this curve, you will basically have 4 sections. And then a curve with the power x to 5, that will have sort of 5 sections, and then so on. But they won't give you these curves. They will mostly give you this parabola, and they will mostly give you sort of this cubic curve. And this method, you are going to use this method to solve out problems like these.